Yeah, okay. I have about an hour and a half before work, and I felt like trying to do something in here. Uh, I see. I just want to see something. How many tabs are you allowed to have? Oh my, okay. I thought maybe if I filled out the last tab, then when I clicked to other tabs, it wouldn't. You see how I can't click on 0 anymore? Anyway, what do we have on our to-do? Junctions should auto-connect. I don't want to do that right now. I/O components. Yeah, you know what? We do need like some interesting things to do. Like, it's nice and all to make like a counter circuit, but you know, the whole point of making like digital logic circuits is to do something. So one idea I had a while back, it's written somewhere in here, um, would be to make like you're making the Apollo guidance computer. Um, in other words, like it's controlling all of the thrusters and stuff on the rocket. Or not, maybe not like. So definitely, I don't want to do like a whole 3D simulation, but having like a 2D simulation. What would the inputs and outputs be? We could have the target position, the current position, um, positions of. No, that's too complicated. Like, if I could have multi-bit buses, maybe it would enter the realm of possibility. What if I did something like driving a car and you want to get it to the other end as fast as possible? Like a line follower. So the inputs would be here. Let me open up a little drawing tool here. Uh, so the inputs would be, so here's your car, right? Here's the line it's following. Those are the wheels of the car. And normally the way these line follower robots work is they have like multiple sensors coming out the front like this. And the idea is that each one sends you whether or not it sees the line. So here in this case, because this sensor sees the line, you would be like, oh, I should probably steer this way a little bit. Yeah. So a line follower might not be a bad idea. I'll put it in the list of ideas. What's something people used to do in like the 80s with their Commodore 64s? I mean, they would put games, they would make games. That's more like coding though. So unless someone's making a CPU and I really crank up the sim speed, that's, yeah, not really doable. Uh, this is kind of tough. I mean, what are the challenges in Shenzhen IO? A lot of them are just like produce this output waveform. Some of them are like, you know, check this key code. Or like, you know, it sends you an input, a serial input, and then you need to change your outputs based on, you know, like the one I'm remembering right now is there's like a hotel door. If it's a special number, then enter programming mode where you scan a key and save that number, and then from then on only open the door if you see that same number. I mean, yeah, maybe just like arbitrary challenges is the way to go. Something that would be nice is if I had like a memory element, like a ROM. Man, I'm actually like kind of at a loss. Um, the only other thing I have on my list here that I would do this morning is the copy paste mode. This is just some minor. I'm not really interested in that. This is it's kind of the same thing. It's like UI changes. Copy and paste would be really handy. Let's just do copy and paste. So I think what we'll do for copy and paste so here over in scan tiles, this always gets it from the map. See, the thing is, when you copy it, that copy should go into some like copy buffer somewhere and stay unchanged. Even if you edit the original area. So using the map every time doesn't really work. So I guess what we can do here is pass in, I don't know, t data. If you pass in t data, the function will read from there instead. The t data should have the same format as the map. That is to say, no. The t data should be a 2D, or it should be a table of tables indexed using t data of y x. It is safe for elements of t data to be nil. Okay? So what we will do and now the last thing we need is function copy area I guess I should probably put asserts like these inside the other one too, but whatever. And wait, how did I do this? No, this is fine actually. So for y, I know, for I equals y up to ey, j equals x up to ex, ret of I equals an empty table, ret of I j equals mget of j I. I think. And what we will also do here is do ret dot meta equals and now we will have function paste area yt data Honestly, we could just do ret.dx equals ex minus x equals equals x plus t data dot dx. Oh. I think I need to do that. And yeah, OX and Y, which is going to be X, Y, where to place, and then finally T data. If not T data, then or type T data does not equal table or not T data dx T data dy. Cover our butts. I'm just thinking about how to do the copy mode. So now we'll do function start copy. Now, those other functions I have, you know, it occurs to me that I could just put these. Whatever, just whatever. So what I need now is the init function. Copy mode equals false. I don't know, copy cell X, copy cell Y. Copy state equals, I guess, TL. We need copy cell EX. Y. So now over here inside of update, we will do if copy mode, then if button push, I guess we'll let it be on Z or X. Now what do we do here? So here we'll do if copy state is selecting the top left corner, then we'll make it possible to select the rectangle in any direction. I'm just doing this now for simplicity. I don't know, maybe I shouldn't call it TL, maybe I'll call it like copy state equals first. And we'll call them X1 and X2 rather than X and EX. And here we will do copy cell X1 is equal to CX, copy cell Y1 is equal to CY, copy mode equals second. Now we'll do that. now what we will do, actually, you know what we can do? Over here in copy area, we can do ex is less than x. This is a neat little trick for swapping two numbers. Let me just convince myself that this actually works. Because I did this from memory, not from an understanding. This is like the XOR swap. So x minus equals ex. So now x, I guess, prime, or x goes to x minus ex. So now here we have ex goes to ex minus x minus ex, which is equal to this is not right. No, I know this is possible, I just forget how to do it. Maybe you need to do, this is less elegant now. Now if it's, let's do ex minus x. So that's now x. And then x goes to ex minus x minus x. No, that's not right. I know, okay, I'm just gonna look it up. Actually, I have learned my lesson. 1 second. It's better if you don't see my Google suggestions. Not that there's anything like, as they were visible on another stream, but I feel it's just a little bit too revealing. Subtraction swap. I know this is possible. It's not clean. Nah, hold on. Where's that famous bit twiddling hacks page? I thought it was like a clean little, like, nice little. All right, let me turn this back on. Now that I found the page, swap. Yeah, it's, you do a minus equals and a plus equals, but then as the last step, you have to write it out like that. So forget it. I'll just use a temp. If it was gonna be like nice and clean like this, I would have kept it just for fun, for no other reason. But since it's not cleaner, we'll do it the normal way. What time is it? I still have maybe 40 or so minutes. I mean, I could have been done by now if I wasn't goofing around, but hey, that's my prerogative. I'll goof around if I want. Yeah. And I think this works. I guess I'll put a comment here. Yeah. Okay. So now over here, now we can do copy area. So I guess we'll just have copy t data. Whoops. Actually, copy cell x1, copy cell y1, copy cell x2, copy cell y2. Yeah, that's it. What would be a good color, I guess? This looks terrible. All right, I give up on writing letters. What's the classic like clipboard? How does that normally look? Is it something like? Yeah, it's not bad. P for paste. Yeah, sure. Why not? We're not quite done. What time is it? It's a bad idea to be, by the way, like working on this before a day of work because like I'm just gonna tire myself out and not get as much done at work. But you know. Um, Something I want to check here. Does rect work if you give it, and I could just try this. So rect, I don't know, let's do color, I don't know, 8 or something. Rect 0, 0, 40, 40. Okay, fine. Now if I do rect 100, 100, 60, 60, does that work? Oh, good. That actually helps me a lot. So in the draw function, background color, draw different color for selected area in copy mode. If copy mode and copy state okay. Copy cell x1 times 8. Copy cell x2 times 8. if Cx is less than, no, Cx plus 7. If Cx is less than copy cell x1, the reason for this is because it's an inclusive area. Shoot. You know what? Let's just do this. So x1 and Cx. Makes our lives easier. So x times 8, y times 8, ex times 8 plus 7, ey times 8 plus 7. And the color, maybe this yellow could be cool. I think I like orange better, actually, so that's color 9. Orange. Then down over here, else if copy mode. Kind of mouthy. It's kind of a mouthful. And just for fun here, local, I don't know what to call this, mode count. Undo mode. Assert mode count is less than 2. Too many special modes. Okay. Now, we're almost there. A couple of more things to do. Where's Gord and Jordan? Oh, that's right, I moved it all in here. Thomas. And then else if t spaghetti. Equals 11. Paste. So now here we will do, I guess, paste area, cx, cy, copy t data. And one last thing. Oh, whoops. Oops. Oh, I guess I'm not. Oh yeah, of course, I do need this. Right, I forgot. We will do copy mode equals true, copy state equals first, right? So, oh man. All right, moment of truth. Oh. Oh. Actually. Okay. So What's going on here? Log, I don't know, hi, I guess. What is this o.state with the house? What is this house? I don't want that. Oh. Okay. Wait, what's going on here? We're getting here. What? Oh. Whoops. That's why. All right, now moment of truth. Hey. Okay. Yeah, and it works in all the directions. I mean, whether or not it is by coincidence, all of my objects have some amount of blank space in them, which means that it works really well for this. All right, so let's do this. Oh. Oh my goodness. Okay, we've got problems. Damn. Oh, I shouldn't have done that. Okay, hold on. I guess I should disable X so that that doesn't happen by accident. So actually, I should really just do this. Okay, so that at least prevents that. All right, now for the moment of truth. Okay, now let's see what happens if you do that without any buffer. Nothing. Now let's check the performance when we fill this place up. Oh, what happens if we paste off screen? Let's try that. Well, it's not clear that did anything bad. Yeah, my performance is bad because of post-con, so what we will do is that's kind of, let's just do that so that it, you know. If stat1, oh, actually, here's what we can do. Tick equals stat 0. Last PC time equals stat 0 minus tick. If stat 0 plus last PC time is greater than 0.99, then debug skipping postcon for performance. Okay. So when we paste, you know what, I'm just going to do this because it'll just save memory here. So in paste area, prevent pasting outside grid boundary. Technically, this is safe, but it wastes memory. EX equals min of 27. Oh. Wait a sec. Wait, I gotta think about this. We want EX, or no, yeah, X plus EX is less than 128. So therefore, EX needs to be less than 128 minus X. Oh, shouldn't I be using GX and GY here? Yeah. Okay. It's a little annoying that copy is so far down, but whatever. I really don't care about the performance blip. Oh yeah, I'll put this in my to-do list. Let me do that right now while I'm thinking about it. I actually just forgot what it was I was thinking. Oh yeah, I remember now. To do, make sure to create a snapshot when pasting. Also, I think we also need to erase all the squares before pasting, come to think of it. I'll put that down. Erase squares before pasting. For now, I'm just doing some performance tests. And let me check this down here. Memory used. So that's already half the memory. If I put down a wire, memory is really cranking up here. Need to call old undos, yeah. Alright, let's keep pasting. See if the performance gets bad. Or if we run out of memory or something like that. And oh, we have wraparound problems. Shoot. That's from pasting. That is from pasting. So my condition didn't work perfectly. Okay, I'll need to deal with that. Let me put that in the notes. Pasting has wraparound problem. Yeah, so now here, if I paste, oh, out of memory. Shoot. We need to deal with that too. Out of memory. Honestly, this is not a bad string there because you got the wide eyes and the face. Anyway, out of memory problems. Sure, let's put the face. Oh man. Alright, let's try to fix that wraparound issue. So this EX, I think we just need a -1 here, and that should solve the problem. Oops. Oh. I mean, whatever, it doesn't matter. Okay, I think we fixed that wraparound problem. Yeah, skipping post-con for performance. And let's see if we run out of memory again when I do this. We probably will. Not yet. Oh, no. Oh, man. What is this? I've never heard this before. I should have been able to guess it was Niels Fromm. Niels Fromm is really good, but ça me donne la déprime. So let's do this. Out of memory. Shoot. Maybe in the undo stack, we should be a little more aggressive. No. One thing we can do is in copy area, we could we could do this first. That might help. Well, no, that's not helping. Okay, I need a little helper here to help me debug this. Print I don't know. Let's do like 85, 10, and let's put this in color 1. Okay. Our performance is fine, so I don't need to look at that anymore. Oh, actually, okay, here's one thing we can do while we're debugging this. Let's just not do any undos for now. Debug disable undo. What? 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 Oh, shoot. That is my 10-minute warning, which is unfortunate. Okay, don't ask me what's going on there. I think I have an unguarded. I was thinking about this last time. Yeah, I've got an unguarded co-resume call. Let's try that again. I've got another to-do here, which is fix the issue where we immediately place a wire after pasting. Okay. Okay, it's definitely the undo stack that's causing problems. Yeah. Yeah, we need to erase the squares before we paste. Although, like, if I just start arbitrarily filling the place up, yeah. Shoot, I've got bigger problems than just the undo stack. If you fill up the whole map, all the data structures just fill up all the memory. That is a much more difficult problem. Now, granted, I haven't made any attempts to reduce memory yet. Um, there's probably a lot of stuff I don't need to keep inside the like gate, net, and stuff objects. Hmm. Hmm. Didn't I calculate though that the grid 128 times 64 times 2 divided by 1024. So a completely full grid is only 16 kilobytes. So who's using up all this memory? It's got to be the registers. That's my hypothesis here. Let's place a register. Oh, also, since we're here debugging memory, yeah, every register uses like a whole kilobyte. What? Why is that? Okay, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to see how many 10 cost. So, before 181.6563, one 192.2188. So every 3-bit register uses almost an entire kilobyte? That's way too much. How is that even possible? They each have a port object. I guess tables are just really expensive. Okay, hold on. Let's open up the... one sec. I'm just going to open up the Pico 8 wiki. I think there's some explanations in here of how much different things use. Oh wow, tables are so expensive. Oh my god. Wow. Yeah, and given that each of these registers has 4 tables in it, then the register itself is a table. So let's try and calculate this here. 32 next power 2 number of array entries. So that port table, oh yeah, the port has a lot of hash entries. They're 20 bytes each. The port table, let's say it has 4 entries. I don't remember. Let's say it has 4. So 20 times 4 is 80 bytes. Plus 32 is like 100 bytes. Times 4 is 400 bytes. Plus the size of the register table itself, which is another 32 plus, say, 80. It still doesn't add up to 1K though. We're still looking at about 500K, or 500 bytes, I mean, give or take. Uh, 192.2188. Okay. I don't know, thing equals deep copy. Whoa! Oh, the garbage collector ran. Let's just try that again. So this was 10 Regis experiment, deep copy experiment, before 141.1318, after 161. Oh, but because deep copy, it'll also copy any connected nets. I don't know what's going on here. And there's something just like messed up here, and I don't know what it is. 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let's do a 100 Reg's experiment. Point 1.7891. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It really is pretty consistent here, about 1K for each register. I just can't figure out where all that is coming from. So what's the formula here? So a gate is, we have the type, the coordinate, what else? Oh no, well, a reg, I guess, is type, coordinate, which gets assigned in place object, t off, lookup value base, lut, state, and then 4 times port, or table of 4 ports. So this is 32 plus, I don't think we have any array entries, so it's 20 times 1, so 1, 2, 3, 4, 5, 6, 7, so it's 20 times 8. So this is table of 4 ports is equal to 32 plus 8 times 4. So this is 192. This is 64. And then a port is equal to we also need is comp. So 1, 2, 3, 4, 5, 6, 7, 8. Let's assume that it is 8. So we have type, num, state, parent, neighbor. So port is equal to 32 plus, I guess, 8 times 20, which is also 192. Okay, so the total is 4 times 192 plus 64 plus 192. Not bothering to do that in my head. Oh wow, 1024. Which is pretty close to the real number. I don't know if that this is okay. I mean, this explains it. if we got rid of this, it would save some space. Oh shoot, what time is it? Oh my god, okay, I'm gonna be late if I don't go now. Well, we've got a lot of issues.